Hello, today we are going to discuss about SOA, service oriented architecture, grid computing and cloud computing. So we'll see how these services are being involved in grid computing and cloud computing. So SOA is one of the common architecture between grid and cloud. So services are there in both grid computing and cloud computing. So this is the most common architecture that you will see anywhere in the world, that there's an interface for means in cloud computing, grid computing or distributed computing, any computing that you will see of high processing computing, parallelizing the machines. So parallel computation will happen in the machine. So this happens with this fundamental three layers. What are these fundamental three layers? First one is resource layer from silicon. So silicon storage happens. High performance resources are there. Means servers are being connected together. These are communicating with each other, solving some problem, job scheduled over them. Storage of large files are being done at multiple servers. How they are being managed? How these tasks are being managed with the help of middleware layers. How these middleware layers collaborate, combine, and work. So it works like that. Web services are there. SOAP request, SOAP messages happens like in case of eucalyptus. So it is having various web services for management of these computing resources and storage resources. So this eucalyptus has various execution of operations that communicate over SOAP protocol, and that various job are being scheduled by users. So these are all being managed through these type of middleware. So Hadoop is also a kind of middleware. It manages Hadoop distributed file system and it manages MapReduce. Spark is also a kind of middleware. It manages a job that you will code in the programming language like in Java, Python, or Scala. You code it and it will be distributed over resources and storage will be used. What happens? Hadoop SDFS is being used for storage, and Spark, a programming computing framework, is being used for processing. Then there's interface front end. So you'll get the result on your desktop application and web client or Android mobile phone. So this is the most fundamental architecture that you'll see commonly in distributed computing environment. Then we'll see URL versus URI. So what is basic difference between URL and URI? URL, you already know that there are various many websites are there. So what are these websites do? These websites basically have URLs that you write it or type it on the browser and it will be open. And but how this Facebook links work? So how means you don't mention anything, any link over there. So these are like URI, resource identifier. So these resource transfer happens means from one resource to another resource. These things happens. So what you can say that there is a resource like you want to transfer to the a video of some account, some user. So you transfer it to the that video, and that video is a resource. It was in web services. It was being said as web resource, and that resource will be used. And how you'll get to that? Through URI. There's some images. So images are there. How you'll get to those images in Facebook? There's basically URI. So what happens? URL is for humans, but URI is for the software, like Android apps are there. It redirects from one URI to another URI, another URI to another URI. So these redirection happens with the help of this URI. So you know this web service dot my sites dot com, this weather service is there. So this is a web service. In this web service, what you can do, this is a URL. In this URL you have this as the URI. So in this URI you put after this the zip code of to request this server of which contains a web service. When you put the zip code, it will redirect you to the resource of web service that has the information of weather at that zip code, and it will send you the uh, response, that is service response, and it will say you cloudy with chance of meatballs. So this is how it works. You transferred the zip code 12345 as the request, and then it respond you as a cloud weather. So this is how web services invocation takes place. That's common in between cloud and grid computing. What happens? Sequence of web service invocation process happens. How this sequence works? Like first of all, you discover a service that provides you some information. That information comes to you that this is a web service and you can access it. Then after this discovery, server will reply you that this is a web service for weather information, and you will get the information. Then what happens? Web service descriptive language, like language will occur that has the information of front end of web service, that is basically coding. So what happens? You will make a soap request according to it in the program with the help of XML. So both WSDL and SOAP request are of XML. So you form a XML SOAP request, and then method invocation will take place. So web service will start executing the business logic, and you'll get the SOAP response, and you'll get SOAP response in the format of XML. So for example, how you exactly should I invoke a web service? So this server sends a WSDL. Take a look at this WSDL. And what happens? SOAP request will be asked by the client. It invokes get weather info with the parameter 1234. 1234 is the zip code in the operation named as get weather info, and then you'll get the response. SOAP response will be there. So cloudy with chance of meatball. So this is the response it will come. Then this is a web service invocation in detail. So what happens in detail? A stub is there, client stub is there, server stub is there. What is stub? Stub is an API that handles marshalling and unmarshalling. What is stub? Stub is a kind of API, means libraries, you can say, some functions, you can say, that actually do what? Marshalling and unmarshalling. What is marshalling and what is unmarshalling? Marshalling is also referred as serializing, and unmarshalling is also referred as deserializing. What is marshalling and unmarshalling? So it is making a request, then it is said to be marshalling. When you are making something and you transfer it to the internet, and that server will get some information, and then it will start doing unmarshalling, deserializing, that it will bring out what are the informations like what is name, what is zip code, what is address. So according to that, it will do the unmarshalling or deserializing. Then it will do the business logic code processing of weather, and that it will transfer you what? It will again do the marshalling. It will put the result of how's the weather, what is the temperature, what is the chances of rain, what is humidity. So these are being marshaled, and it will go to back to the client, and client will do what? Again it will do unmarshalling or deserializing, and it will get the information of weather, temperature, humidity, etc. So marshalling is being done by client, then unmarshalling is being done by the server, then again marshalling is being done by the server, and you will get the, as a client you will get the response, and again you will do what? Unmarshalling. So a stub is an API that handles marshalling and unmarshalling. So stub is the coding logic and predefined something like in Hadoop, in Eucalyptus, there are operations or functions. You will do the marshalling and then send the data to other server. Then server will do some processing. It will do again marshalling and send it back to you as a client, and Hadoop will do unmarshalling on your behalf. So you don't have to worry about marshalling and unmarshalling. Marshalling and unmarshalling would be done by the APIs and coding. So this is the sequence. Like SOAP request is there, and SOAP request is being marshaled or serialized. Then it will be transferred. This SOAP packet or SOAP request has been transferred on HTTP protocol, and then unmarshalling will take place. So unmarshalling or deserializing will take place. Then SOAP request will uh, be deserialized or unmarshaled at server side, and you will get what? It will do the processing. It will do the processing. Server will do the processing. Web service will do the processing, and again it will transfer as a fourth one here. SOAP response is then again marshalling being done at this part by the server stub, and you'll get the information transferred over HTTP protocol. So server will put the marshaled information SOAP response on HTTP protocol, and then on the client side you'll get SOAP response, and what you will do with that? You'll do the unmarshalling, means you'll get the core detail from that, and as the sixth step. So this is client sub. So the client side code that generates SOAP request and interprets SOAP response sent by the server. So this is the part of client stub. Means client stub is a kind of code that generates SOAP request, and client stub basically do interpretation of SOAP response sent by the server. What server stub do? Server stub do what? Server side code that interprets SOAP request sent by the client and generates SOAP response. What two things server stub do? It interprets SOAP request and it generates SOAP response according to the business logic. So this is how web service works. Now this is discussed for the SOAP based web service. Similar thing happens in the RESTful web service as well, that we'll see in the uh, next chapter. We'll see. So what happens? SOAP has user that a coder can define its own operations. But what happens? Uh, RESTful web service coding is little easy. It is having only crude operations and very few operations well defined: get, put, post, delete, update. So this is how, so these are the only operation, and they transfer from one resource to another resource, and link transferring happens in that. So that is little bit easier, and that do not ask for much coding. So that is RESTful web service. But in SOAP-based web service, lots of coding happens, and you have to form a client stub, server stub, and you have to push the response on HTTP. This is how it works. So this is how a web service invocation. So what happens? Web service is there. So SOAP engine will do the processing, and SOAP request will be formed, and it will be transferred to the application server, and application server will push the final packets or the final SOAP request or SOAP response to the HTTP web server. So this is how the four layers of web service works. Then the basic difference between grid architecture and cloud architecture we'll see. So what happens in older times grid architecture, it was said that there is a fabric layer. What is fabric layer? Fabric layer is the part of grid computing that actually provides different resources like computation, storage, network resource, code repository. So all these are fundamental infrastructure layers, and infrastructure silicons are there: storage, computation, network. So these are fabric layer. Then connectivity layer. What happens in the core? Communication or authentication happens with some network or some information. So this is being taken care by connectivity layer. So there is specific protocol that works for the authentication, and some secure network transaction takes place. So that defines communication and authentication between the two computers. Then resource layer is there, which actually defines protocol for some publication. Discovery means monitoring, accounting. So this, and sharing of some operations on the individual resources. So these resources, how these are being managed, information is being gathered, or understanding is being done, are taking place at resource layer. So this accounting, monitoring, and payment sharing, these operations. So what is operation? Operation is business logic and coding, fundamental coding happens at resource layer. Then collective layer. What does collective layer do? Collective layer do collections of interaction between collections of resources. Means it is a cluster controller or cloud controller, you can say. So collective layer will do what? Discovery of some service, and it will find out where the services are being stored. So monitoring and discovery takes place at collective layer. Then application layer, it is the fundamental browser based, or some apps are being developed. So application layer is being managed for whatever application is being built on top of all these protocols and APIs. So this application layer is front end, you can say. So what are the layers of grid computing? Fabric layer, connectivity layer, resource layer, collective layer, and application layer. So these are the five layers in grid. And now we'll discuss what are the layer defined in cloud architecture. In the older time, this fabric layer is being said. So what fabric layer do? It is the same as grid computing. So hardware level resource management, computation, storage, and network resource management takes place. And nowadays, this layer is also been termed as infrastructure as a service layer. So this part has been done at fabric layer, infrastructure as a service part. What in the older times, unified resource layer is also been defined. So what is unified resource layer? It do the resource management like abstraction, encapsulation with the help of some virtualization, VM creation, or operating system management. So these are the that can be exposed to the upper layer and to the end user, and that will integrate the fundamental hardware resources, storage resources. So this is unified layer, unified resource layer, which helps you do the virtual computer or clustering or management of file system, logical file system, like in case of Hadoop distributed file system, Google file system. It also do the database management system. So these type of properties are being done by the unified resource layer. Now, this unified resource layer combined with fabric layer together being said as what? Infrastructure as a service. Nowadays, what happens? Platform layer in the older time, platform layer is being said, which is exactly platform as a service nowadays, which actually have platform layer and a collection of some tools, middlewares, and services running on top of unified resource layer that actually provides what? Development and deployment environment. So, for example, web hosting environment, scheduling of services like Google App Engine, Heroku, and Ruby on Rails on Engine Yard. So Engine Yard is a kind of platform as a service. Heroku is a kind of platform as a service, and similarly Google App Engine. So they are the platform layers. Now there's a small contradiction that this database system is the part of platform layer. So you can say that this, except this database layer, everything in the platform layer is platform as a service. Now we'll move to application layer. It's very common, very basic software as a service, which works above platform layer. That is from the browser or the apps, you can access it and you can run on Android, iOS, or some browser. So this is like Facebook is a application layer service. So it is software as a service, which works directly on the full cloud. What Facebook do? Facebook do all these things. All these things are being done, and you'll get the app on Android, and you can on browser you can log in and use the Facebook. But what Google App Engine do? Google App Engine provides only this thing: fabric layer, unified resource layer, and it will also provide you some platform layer. So these things are being done by the Google App Engine or Heroku or Engine Yard. Now this thing is being done by the Eucalyptus or Hadoop distributed file system like things. So these are the middleware part. So this is how correlation between architecture and cloud architecture. So now what happened? This connectivity layer and resource layer are combined together and said as unified resource layer. And platform layer has been changed from collective layer. So collective layer is transformed to platform layer, from grid to cloud architecture. So this is history that we are studying. The application layer is still application layer. Now what happened? This all layers are being influenced with the fundamental concept of service technology. So all these things are working on service technology. It was there in last 20 years when there's grid computing is there, and it is still today when cloud computing is there. Service technology is the same, and this is the fundamental part. And even the services have operations. So what happens? In older time, what operations are being termed as? Operation are being termed as remote procedure calls. So in older time, in fundamental distributed computing 30, 40 years ago, so there is still some remote procedure calling happens. So these are the layers, fundamental layers in the architectures of grid protocol and cloud protocol. Application layer is there, collective layer is there, resource layer is there, then connectivity layer is there, fabric layer is there. So silicon is in the fabric layer, then networking connectivity layer, resource monitoring management and abstraction, all these things are being done at resource layer. Collective layer means other things like resource discovery happens at collective layer and then application layer. Now they had reduced the cloud architecture and fabric layer is the silicon layer. Then unified resource layer is which helps you do the connectivity and resource management abstraction. Then platform layer is some middleware that helps you do the development and deployment and do the database management layer. Then application layer is when you deploy the final application and you made it accessible to the user. So these are the fundamental theory of cloud architecture. Now this unified resource as well as fabric layer combined together and said as infrastructure as a service. Platform layer is said to be platform as a service. Application is said to be software as a service. Now in next class we'll see transactional on demand and distributed computing. So any query or any doubt or discussion that you wish to do in the grid and cloud architecture, like web service invocation, URL, URI, common architecture, then marshalling and marshalling, grid, fabric layer, connectivity layer, resource layer, collective layer, application layer. So thanks. In the next class, we'll discuss about transactional on demand and distributed computing.